Welcome to my channel. This is Bratin Das. I did my MSc in Statistics from Calcutta University, then MTech from ISI Kolkata. 99 MTech, so having a little over 26 years of experience, of which 17 years in industry with TCS, IBM, Cognizant, and then 7 years in teaching with Macau, Calcutta University, Ali University, NIT, Nimrana, and currently I'm with ADAMAS University, Barasat. So I will be preparing very short videos on probability and data sciences. We will be health student. So this is the idea. So this will be my first video. So support me. I'm starting with the very basic thing, data science. So nowadays we heard many about the data science. Now, what is data science? What is data science and why do we need data science? That's the first question. Why do we need data science? So let's take one step back and see, before data science, what we have. The very strong and robust method regression was invented long back 1809, and then we have another method called Fisher's linear discriminant analysis, long back in, I believe, 1938. And another method is logistic regression, which was invented in 1956. So we had these three methods for a long time, and we are quite happy with that. Now all of a sudden, why we are moving to data science? Let's try to answer the question one by one. So there are few things. Let's try to answer the questions. So why data science? So we need to have a few assumptions to apply regression, logistic regression, and Fisher's LDA. Now let's see what are the assumptions. The first one, xi, the observations. This can be written as xi plus ei. This is the actual value, this is the predicted value, this is the error. So whenever we fit a model, we have to have some error. The error may be positive, error may be negative, error may be zero. So here our first assumption is EI is our IID with n mu sigma square. Now what the term IID means for I from 1 to n. So what the terms IID means? IID means independently and identically distributed, means it will have the same mean and same variance. Now question is, if the distribution, if our xi's are not from normal distribution, then what we have? Regression, logistic regression, Fisher's LDA will fail. We need to transform the data to xi's to satisfy the conditions. So this is the first problem we face. Now what about the second problem? The second problem we face is problem of multicollinearity. Now what is multicollinearity means? Multicollinearity means, suppose this y, that the dependent variable, we are trying to explain through one of the n variable x1, x2, xn. Now if any of these xi can be expressed as a linear combinations of the remaining variable, any of the variable xi can be expressed, this f is linear here, can be expressed as a linear combination of the remaining xi. We tell that there is a multicollinearity problem. So let's take an example. For example, QBMI. We know all QBMI. What is that? Queulette body mass index. Queulette body mass. So to take care of multicollinearity problem, we calculate something called VIF. It is kind of a partial correlation. We called it variance influence factor, meaning a particular variable has how much influence on the other variable. So if this VIF, we can call a function in R or Python, it will calculate the VIF for each variable, and if it is greater than 10, we will drop the variable. We'll see that variable is creating multipolarity, so we don't need that variable in our model. As simple as that. If it is greater than 10, sometimes it is greater, tell it's greater than 5. Anyway, we'll stick to 10 value. So this is the second problem. Now what is the third problem? Third problem, we will see the problem of homoscedasticity. Homoscedasticity. Now homoscedasticity means equal variance. So Vi equals to sigma square for all I. We assume, you remember the first assumption. So if Vi is not equal to sigma square, what happens? The assumption breaks and logistic regressions or Fisher's LDA cannot be applied. So how to check whether the homoscedasticity is breaking or not? That's a mini test. We'll stick to some basic thing. It's called Bruce Pagan test or BP test. You can just call in R or Python a particular thing and it will give you the BP test. We'll test if the value of the statistics is greater than 0.05 or not. If it is greater than 0.05, H naught is rejected. H naught is rejected, meaning they are not homoscedastic. There is a heteroscedasticity. Okay, so this is a third problem. And fourth but last problem, we have something called problem of we measure it by Durbin-Watson statistics. Problem of autocorrelation. Now what is autocorrelation? If in our problem, if I have to measure a particular variable more than one time, so a variable is taken into account for more than one time. So for example, we are doing a study on the low birth weight baby. So during gestation period, we are taking the weight of the mother. So we have taken the weight at the fourth week of pregnancy, 22 weeks of pregnancy. So that weight of the mother, that particular value has taken more than once. So in that case, there is a chance there is a autocorrelation. So autocorrelation we measure by Durbin-Watson statistics. It is defined as D. D is nothing but ET minus ET minus 1 square, where T runs from 2 to N, this square by ET square. T runs from 1 to N. Now typically the value of D lies between 0 and 4, and if D is very close to 2, we say there is no autocorrelation. If D lies between 0 and 4, we say negative autocorrelation. If D lies between 2 and 4, we called it there is positive autocorrelation. That's it for the first video. We'll make video on regression, logistic regression, Fisher's LDA, and coming all this. Thank you all.